Welcome to iDAC Presents Facade and Beyond Summit. iDAC, India's largest knowledge sharing platform, which supports innovation in the industry, is bringing together acclaimed professionals from the build industry who forte in facade engineering and design. iDAC welcomes each of you to the studio virtual summit called Facade and Beyond, a knowledge series on facade and fenestration. This will throw light upon various technical aspects of the facade industry, like sustainable facade, traditional facade versus modern facade, aesthetics of facade, climate-based facade, and more. In detail, all of this is going to be explained through case study presentations, panel discussions, and keynote sessions. I would like to take this opportunity to thank our title sponsor, TimexBond ACP HPL, along with our supporting partners, VS1 and Pidilite Industry. A special mention to our supporting association, IGBC, for their expert opinion. I now invite Mr. Jinesh Gala from TimexBond to open our very first day of the Facade Summit.
A very good evening to all our valued speakers and audience on this knowledgeable and informative two-day summit on facade and fenestration. It gives me immense pleasure to walk you through what we have in store for the first day of the summit. Our first session is a keynote presentation by Ms. Dweik from Thomas Bell Wright, sharing her views on how the pandemic will shape our future facade designs. Followed by the keynote presentation, we have a case study presentation on Lodha World Towers, presented by Mr. J. Berman from Halls Lane Studio, New York, and Mr. Nitin Bhatia from Facet Façade. Our last and final segment for day one of the summit is a panel discussion where we will throw light upon collaborative efforts in facade designs. Our moderator for the same is architect Ravindra Kumar. Our panelists for the panel discussion are Ms. Gayatri Kapur from Vistara Façade, Mr. Arunjot Singh Balla from RSP India, myself from TimexBond Industries, architect Tilak Thomas from Thomas Architect Associates, and Mr. Anwar Mead from Edel. I hope you all have an educative session and you all like it. Thank you for joining us this evening. Thank you.
Invite Ms. Sandy Dweik of Thomas Bell Wright to take us through our very first keynote session. Sandy Dweik started her career with Thomas Bell Wright International Consultants in 1997 as a facade consultant and is now in charge of its operations as CEO. Sandy has seen closely hundreds of projects which have changed the skylines of city across MENA and the Indian subcontinent. As an architect, not only has she reviewed thousands of facade drawings, but also conducted countless inspections in manufacturing locations and on the exterior cradles of tall buildings. Through the past decades, she has contributed to spreading market awareness and ensured the quality and integrity of all that the company delivers. During the past few years, she has witnessed interesting trends in the market towards an economical, efficient, sustainable, high-quality facade. As a leader of one of few companies around the world that provide facade technical reviews, curtain wall testing, and fire compliance under one umbrella, She brings forth a very unique technical insight that she often shares on various platforms, including conferences around the region. And this evening with us on iDAC. Over to you, Ms. Dweik.
So, hello everybody. I would like to thank iDAC for inviting me to speak in this event on facade design, techniques, and innovation. The subject that I'm going to discuss is the impact of the pandemic on future facades. In this presentation, I will share my observations during the past year on how the pandemic has affected facade design and construction process, and whether this will have any implications in the future. My name is Sandy Dweik. I am the CEO of Thomas Bell Wright International Consultants. I will share my presentation with you now. I hope I'm sharing the screen fine. For those of you who might already know us, we have started 25 years ago with facade consulting and curtain wall testing. And then we expanded into fire testing of materials and systems. We are based in Dubai. Our company is accredited by UCAS as a test laboratory, a certification body, and an inspection body. We try to think of ourselves as a one-stop shop for all services related to checking facade compliance, including laboratory testing, fire testing, inspections, shop drawings reviews, everything related to delivering a high quality facade. So back to our subject, which is the pandemic and how it has affected the facades. So basically, we all went through this painful experience this year, unfortunately, where a new virus was detected in China, and then it spread gradually to the whole world through travel and contaminated surfaces. In order to contain the spread of the virus, many countries imposed voluntary or compulsory restrictions on travel, on movement, going to work, going to school. And the result was that many people spent a lot of their time at home or confined in closed spaces. So during these difficult times, people felt down, they felt pressured, and they wanted to connect to the outside. And the only connection to the outside was through their facade into their surrounding, which can be the facade next door or the street or any other view that they had around them. Of course, human beings by nature are artistic. They tried to make the best out of this. Some people decorated their surroundings. Some people decorated their facades in order for other people who look at them to be, happier. So with people spending more and more time at home, an ugly view such as this one on the top right became very disturbing at times. And whereas if you have a neighbor who was doing a roof garden or took care of his surrounding, this was much more appreciated. People were looking outside their buildings. The height of openings became very critical. The height of rail barriers also very critical for you to see the outside, to be connected with the outside world. So ironically, for example, right now, I'm suffering of being COVID-19 positive. and I am isolating myself at home for 14 days. I have 9 days more to go. This vertical picture in the middle here is my view to the outside world for half of this month. And I'm very grateful that there is a tree that I can see outside without moving much in my room. And this has become a driver for people to move even their residences, to change them from residences that are looking outwards into through the facade into a nice surrounding. I would like to also point out that roofs became very important. In some countries, there were curfews where people were not allowed to go down in the street. Many people walk their dogs on roofs or spend some time to get some fresh air on the roof itself. With homeschooling and working from home, the line separating work and residence became blurry. It became mixed up. Many companies have already set up for their workers to do their work from home. And this had some advantages that such companies have noticed, and they might implement this on the long run because it has its pros and cons. So people try to make the best of the situation. They try to make their surroundings better. So for example, this is a balcony that I'm showing a small video for, a balcony for one of our managers here at TVW, who have decided to make it more green in order to be more usable. The impact was the same on commercial to keep their employees safe. Some companies worked in shifts to enable safe distance or allowed some of its personnel to work from home. The office space itself became a place for brief meetings and planning rather than for doing the work itself. Online cubicles or smaller meeting setups physically in the office is now more the norm this year. And in a way, the demand on office space has changed a little bit, and with the possibility of having a remote office that is less expensive, be linked with the main office. Decentralized offices are also a consideration for the future. So during all this, of course, our duty as engineers was to continue building and striving to deliver a high quality facade. A high quality facade is a sustainable facade that can survive the 25-year design life of the building with minimum amount of maintenance. So it's not only the 10-year warranty period, it is the design life of a building of 25 years that we all have to work very hard to build as a high quality facade. The team consists of many people: project manager, consultant, facade specialist, system designer, the contractor. All these people are stakeholders who are now trying to work during these difficult times to deliver a high quality facade. The process starts at the early beginning with having a proper tender package with the correct specification, with the proper design drawings, where you submit, where the consultant prepares a tender package. The contractor has to make sure that he understands the requirement of the consultant and that this tender package is clear. During construction, the contractor submits shop drawings to explain his proposed system. He submits system drawings, test reports, installation reports that should all be reviewed by the specialist, reviewed by the consultant. It is highly advisable to have a third-party reviewer to assist the team during this process in order to make sure that we go through these difficult times correctly. But why is the process more challenging this year, and why it will be challenging from now on if we continue with this trend? So we are all working from home now. We were pushed into a sudden shift in collaboration and checking process to be more electronic, more distant. With the restrictions on face-to-face interaction, you need the expert eye that is trained to find discrepancies, and you need the expert opinion to give you solutions and oversee any problems before they happen. So we all have to work together, the contractor, the consultant, facade specialist, third-party reviewer. We all have to work in order to deliver this remote system delivery, to do it properly. Also, the interruption of supply chain in some industries have moved projects to choosing locally available material and systems to avoid such interruptions. In some cases, the new materials are not exactly the same as what was used before, and they should be reviewed and tested in order to make sure that they serve the same function and they work efficiently together. So while all the stakeholders are doing their best to meet these deadlines, this has also become a crucial part, finding alternatives and making sure that the alternatives work, because the work has to be resilient enough to take some changes and to be reviewed properly for such changes. The testing process itself also is undergoing some challenges. So in order to validate the design, excuse me, a representative of the system should be installed at the laboratory before installation starts at site. In some countries, laboratories are not available, and these mock-ups are shipped to the lab, and where testing and installation is witnessed remotely. Mock-ups are also assembled remotely with remote supervision. So this is also a change that might go on for a while now, and it might be also proven useful for the future. I would like to draw attention to the importance of some site tests that have become much more relevant, much more important, such as the whole building air infiltration test. So this picture on the left is for a fan for the whole building air infiltration test. This measures leakage through the whole facade of, let's say, one full project, one full story, or one full volume. It doesn't only measure one item, it measures leakage through the roof, through all the walls, how everything works together. An efficient envelope is an envelope that works properly. It is an envelope that does not have any leakage. So therefore, you don't have to put your air conditioning on all day to compensate for leakage. You don't have to put your heater on all day to compensate for leakage. So during these difficult times, you don't want your power bill and your electricity bill to go up because of an inefficiency in the facade. Very important other test is a balustrade test. People spending more time on balconies, children spending more time on balconies, leaning forward. This can be tested. Balustrades can be tested for point loads, for distributed loads. And I think this is becoming very, very important. Also, site testing to validate the construction on site with the delay in material reaching the site and the difficulties of construction at the moment. It is very important to make sure that each facade element is working properly according to the performance requirements. There are other important tests for materials and systems which should not be overlooked as well. It is important to specify, choose, and install material with the right combustibility as per the code requirements, and systems that are compliant as a whole, that do not spread a fire in case it happens fast, and gives time for firefighters to manage such a fire. So if you are having a project where these specific tests are not possible to do for your project, such systems are already which are already certified and listed can be chosen for your project instead. So such systems have already been sampled in a controlled manner, tested, and certified and listed in a specific portal. Like, for example, this is our certification portal, tbwcert.com. You can go there and pick a material or pick a system that is already proven to meet the testing requirements, meet your local regulation, because this is very important and you would not want to have a project where there is a hazard that might happen later on. So with higher building occupation rates, with people spending all their time in residential buildings, the risk is higher, and injuries, the number of injuries might be higher due to the crowding and the many people using the buildings for longer time right now. So developers and building owners should really be very careful with all what they are building from now on, because their reputation might suffer in case their projects catch fire, and the expenditure at the beginning to choose the right material, to choose a certified system, of course, will be rewarding later on in order to avoid such events. Inspection is very important because it's the last step of verification, and it can catch many non-compliances such as deviations from submitted shop drawings or workmanship faults. The project team might have suffered from having some of its members stuck in a certain locations, or had groups of workers who were infected, and then other group of workers might come back and affect the workmanship. In order to be sure that the installation is 100% correct, a skilled third-party inspector can assist the team spot any non-compliances, so they can be amended while the project is being constructed, and not at the end where any work has to be repeated. People have not had the chance to go out. They are not spending on clothes, on cars, or whatever, but their number one priority has become well-being. So during World War I, the people who were sick, they were put outside to die or whatever, but they discovered later on the healing power of the sun and the proper ventilation actually helped many people overcome many diseases, such as the Spanish flu. And this is translated in today's language to vitamin D, proper ventilation. All of this have made people much more conscious to their well-being and what the facade can do for them. Do they have balconies? Can they go out? Is there an area in the sun where they can actually take this vitamin D? So this has become a priority for many people. And not only have people experienced views, external areas, and so on, people have had now, as building users, as inhabitants, they have had the first-hand chance to experience what an efficient facade, which is thermally broken, can do for them. And a facade that does not have leakage. So for example, if you have a window that is letting in the outside air, you are having to put your AC on all day, your air conditioning, your heating, all of this has now become much more known to the public, much more known to building inhabitants. Bad workmanship and leaking windows and facades contribute to up to 40% of the increase in your electricity bill. And people have sensed that in these difficult economic situations. So again, I would like to emphasize the importance of proper design to have a proper thermally insulated facade, and inspections and execution in order to avoid leakage. The use of facade also is very important. Clutter on balconies or fire escapes has increased recently, and this is a hazard because you want your fire escapes to be empty. You don't want a source that can ignite on the facade. It is not only the consultant, the contractor, and the people who finish the project, it is also the project user who should be aware of these considerations and the potential source of hazard that can happen with clutter. So at the end of this presentation, I would like to say that I hope the restrictions that we had during this pandemic will end soon. However, the impact of the last few months on the economy might force people to think again and be more creative about workspaces, about residential spaces. And I'm sure that this will be the trend from now on. The ventilation is quite important. Everything that is in a sustainable building requirement, such as views, ventilation, execution. So for example, according to a latest study, concentration of the virus in Wuhan itself in empty hospital was much more in closed areas, such as bathrooms. So the virus stayed for a month afterwards, after evacuating such hospitals. So these questions are the ones that we can ask in the future. For now, the considerations that we should take is that during this pandemic, people were forced to be indoors for a long time. So they connected to the outside world through the facade, and they were surrounded by other facades. So not only do they enjoy having an interesting and aesthetically pleasing facades, but also they understood what a sustainable facade is. They understand a thermally efficient facade, what it means to them. And maybe it is our duty as engineers to explain this in basic language and say, for example, when your U value is this much in the facade, this is how much you are saving on your electricity bill. And that this is an airtight facade, it was tested, this is the evidence. All of this will be a requirement from now on. People will make this due diligence before they invest and before they put their money to buy a residential unit or a commercial unit, because this makes the difference from now on, and people are much more aware about their well-being. Views are important. Roofs should be designed to be visually pleasing. Thermal efficiency should be explained in simple language, as I just said, to the building user in order to explain the impact on power bills. Reviews and verifications by a third party, by a specialist, has become more critical with an online decentralized work approach. We need all the help that we can have as a team from specialists in order to be sure that the way that we are moving forward is correct. As engineers, as facade designers, as facade reviewers, it is our duty to contribute and to have a high quality facade that will reach for a project to reach the design life. So this is my presentation, and I hope that this was useful. Thank you very much. And if you have any questions, please email them to me or email them to iDAC, and I will try to answer as much as possible. Thank you very much. I hope you stay safe, and let's all work towards designing high quality facades, delivering high quality facades. Thank you.
Good evening, ladies and gentlemen. This is Satyan on behalf of Pidilite Industries. I am looking after the wall insulation division for the past 1.5 years, and I myself am an IGBC AP in the field of insulation for more than 1 decade. So here's what I want to present to you. Good evening, everyone. This is something I would like to talk about to you is the low energy consumption system, which Pidilite has been doing for past few years. And today we'll be talking mostly about insulated building envelope solutions from the Dr. Fixit division. Let me tell you, friends, today the most concerned part in today's environment is about energy. The most talked about part is energy and its environmental impact. Today, our building sector consumes 36% of the total energy produced, and it is expected to rise steeply up to 55% by the year 2045. And let me tell you that 65% of the energy which we generate is through thermal power plants. And the cost of this energy generation is very, very high, and it has a very high CO2 emission. And India has made its commitment to the Montreal Protocol that it will reduce its emission intensity by 30 to 35% by the year 2030. And for this, the Energy Conservation Building Code has been framed in the year 2007. And it was then revised in 2017. And this ECBC code is framed by the Bureau of Energy Efficiency. And the survey says that if the code was implemented in 2007, we could have saved 4.3 billion units of electricity. And to add on to that, 30 million metric tons of CO2, which is very, very high. So this talks about the code in brief. Let me tell you, the main objective of this code is to provide the minimum energy requirements for an energy efficient design for a building envelope and the complete building. The scope of this code is applicable where a building has a connected load of 100 kilowatts or greater than that, or even a contract demand of 120 kVA, and the building is intended for commercial usage. The ECBC compliance can be achieved by the prescriptive method and the whole building performance method. And let me tell you, the prescriptive method is the most easy way to achieve the ECBC compliance. And this can be achieved by new and old construction as well. This is a table where you will come to know about what the prescriptive method says. The prescriptive method talks about the U value, U factor for the roof, as well as the wall. Here you can say India has been divided into 5 climatic zones primarily. One is the composite, one is the hot and dry, the warm and humid, the temperate and the cold. So on that basis, you can clearly see what are the requirements for the roof and wall. The roof definitely has a stringent requirement because the heat gain through the roof is maximum. So that's why you will see the U value is very low for the roof rather than the wall. So what are the challenges for the facade system? When we come to walls, the present facade systems has its own challenges. So these are the challenges which our facade system is facing now. The one is it has a very limited aesthetics. Then it has a very increased capital cost and operational cost. It has less thermal comfort for the occupants. It also has a very heavy heat gain. Also, the maintenance cost of the facade system present is very high. And most of the facade systems where materials are not so environmental friendly. So how to face these challenges and to eliminate this them, what can we do? So for roof and wall, Pidilite Industries Dr. Fixit division has come up with 2 very good solutions. This is about what we have for the roof, a brief video of how the system works. So that was our solution for the roof, a continuous insulation roofing system with a very high SRI of more than 100. Now let's move on to the wall part. What do we have for the walls? This is what we have for the wall. So that was our wall insulation system. Now what are we going to achieve with these kind of facades and roof systems? So these are the basic key features and benefits of our LEC system. The one, the minimum heat gain through your walls, which is resulting to the thermal comfort of the occupants. Then we are giving you waterproof and crack-free wall. Also, these systems are very fire resistant, and you can have a choose of different colors because it offers you in various colors. And with this wall systems, you can also achieve the ECBC compliance for new as well as retrofit systems. And it will give you a payback between 3 to 6 years. It will also give you a saving in your refrigeration tonnage on a heavy basis. And as a result, you will have reduction in your daily running bills and the improves efficiency of your occupants. Also, these systems are very low maintenance and it will give you a very faster ROI. And we are equipped with a well-experienced application team who have been doing projects for almost a decade in this system now. These are few of our projects to credit in India, where you can see they have been looking beautiful, as well as they have been performing well in their aesthetics and as performance, and the energy bills are concerned. So also you can see the DLF Mall of India here, also Infosys Jaipur, and presently we are doing a hospital in Noida, Faridabad campus. So these systems are very much aesthetics and very much performance based. And you can see, ideally, you can achieve an aesthetical look for the architects as well as a performance base for the developer. So this is a win-win situation for every one of us. Thank you. Thank you, everyone. That's all from my side.
Our first case study for today comes to you from architect J. Berman and Mr. Nitin Bhatia, who will be presenting India's tallest residential building, the Lodha World One Towers. J. Berman, director of Halls Lane Studio. He harnesses more than 2 decades of global practice and diverse expertise in the built environment. J. Berman established Halls Lane Studio in 2020. The studio works at multiple scale and undertakes a broad spectrum of projects, ranging from individual architectural commissions and advisory assignments to urban design, development, and planning initiatives. As a design partner at Peacock Fried and Partners in New York until 2018, he led academic, institutional, headquarters, office, residential, mixed use, tall, super tall, and renovation repositioning projects. Prior to founding Halls Lane Studio in 2020, he served as Chief Planning and Design Officer for Lodha Group of Pallava City, directing the overall planning and design process for a 5,000-acre development northeast of Mumbai. Closer to home, Mr. Nitin Bhatia of Facet Façade. Nitin is the founder and principal consultant of Facet Façade Consultancy. Since establishment in 2004, Facet has steadily grown to become a leading facade consulting firm in India and have executed some of the notable projects in the country. They have also executed projects in Dubai, Abu Dhabi, Kuwait, Nigeria, and Bangladesh. Facet have closely worked with leading architectural firms and developers including Goldman Sachs, Lodha Group, Oberoi, Tishman Speyer, Trump, Turner, DLF, Heinz, HP, Microsoft, Qualcomm, HOK, SOM, Peacock Fried, Benoit, Woods & Bagot, Hafiz Contractor, among many more. Over to you all to walk us through this iconic project.
Hello everyone. Good evening to you and good morning, Jay. Hope you're doing well in New York. And I see it's still sort of dark outside. Probably the day's about to break. So how's it been?
Good morning and good evening to all of you. It's great to join and great to see you in, not quite in person, Nitin. It's been about a year pre-pandemic.
Yeah, that's
really happy to be here to join the conversation.
Sure, and thanks iDAC for bringing us together again. Though we are not on the project site, but we're still going to be talking about the project, which we often did some time back. So, well, it's great to be talking about the towers again. What an amazing project, superbly designed and engineered through and through. So I suppose let's get cracking with it and let's hear it from you.
So I'll start, but I think maybe we owe it to the audience, Nitin, just to quickly describe the fact that we have worked together on facades in India for almost 15 years.
Wow.
You were one of the first people I met along with my team when we started working in Hyderabad. And it's been, for me, an exemplary collaboration.
Thank you.
You make my work better. I hope I help your work along.
Thank you so much. I'll take that as a compliment. And it truly has been amazing to work with PCF on and you and the team on I think so many projects that Wavebrock, Goldman Sachs, the Lodha Towers. It's been absolutely amazing. It's an amazing journey, and I think we built a great relationship through these years and worked with some wonderful people. It's been really, truly a great experience.
And I think we've kind of grown up with the curtain wall industry through all of this development that's going on in India as well. maybe a little bit of that'll show in the presentation.
Sure, absolutely. I think we both pulled along the industry to quite an extent through these projects. So let's start on then.
Pulling up the presentation.
Yeah.
It's there, everybody can see it?
Yep.
So I've put together a presentation on our work at the World Towers in Lodha Place. This is work that has gone on now for more than a decade, starting with our master plan, which I'll describe a little bit, and how that emerged and developed into architecture over a long period of time. Much of which, of course, involves facades. A project this large, which involves great amount of interiors, great amount of planning, but ultimately the expression of the project, the image, the iconography of the project comes through its facade. So those have been very important all the way through. I did this work on the World Towers almost entirely as a partner at Facade Beyond, where I was for 20 years. Subsequent to that, I actually joined Lodha in-house to work on a very large planning project called Balla, an extraordinary experience. And then post-pandemic or during pandemic, I've been more based in New York and have established a consultancy here doing architecture and planning called Halls Lane Studio. And essentially I'm doing the kinds of things I've done my entire practice, albeit from a different platform. On the screen is an aerial view of Mumbai circa 2008, 2009. SB Road. See if you can get the pointer. It should work. And the site on the right of the screen. You can see it was an undeveloped mill site, and we were approached by Lodha in 2009 to master plan this site and to begin an iconic development, which they imagined would really be their signature going forward. I'm going to skip through a lot of this, but when we began this project, we had been approached by many developers many times to do projects in Mumbai on mill sites. And we rejected almost all those opportunities because everybody just wanted to go ahead and build buildings. A 17-acre site in the middle of Mumbai, such a major opportunity. And for us, it's a major opportunity to make a piece of the city, not just stuff that happens in the city. And for us, as we looked at the site with its very small amount of frontage on SB Road, but very incredible location, we said that the actual major opportunity here was to make a place. And the red line curved on this screen that you see is actually, over more than a decade, the most important thing we ever did on this site. Because Lodha Place is a place, it's a street, it's a part of the city, and all the buildings, almost 6 million square feet that we've built in the subsequent time, relies on that for its image and for its iconography, really at the ground as much as at the skyline. Some quick diagrams from the end of the master plan stage, which took about 6 months, in which we had organized the site and figured out the major outlines of how the project would proceed. An avenue, or a lane as we call it these days, with a gentle curve. 3 very tall residential towers, and 2 gateway office buildings. And of course, it's a very significant amount of important amenity space for the residential towers. And just importantly to us, a major amenity space with a major public park with active retail for the city. Over the next period of time immediately after the master plan, we developed an idea about architecture and what buildings would really look like, but also how buildings would integrate with the city, and how, most importantly, and this will be a theme as I discuss the rest of the project, how does, what ultimately ended up being 6 major buildings, 3 residential towers, 2 office buildings, clubhouse, and a whole lot of interstitial tissue which connects it together. How do those hold together visually in terms of image, in terms of identity, but also how do they each have their own identity? How do they relate to context? How do they relate to history? How are they specific to the site? There were 2 ideas we had at the very beginning, which held through the whole process. The first idea was that this was a textile mill initially, and there was a kind of there was a cue to us from that aspect that has informed all of the facade designs. All the facade designs have this idea of being textures or fabrics, weaving, and the tectonics and the visual aspects of the facades all relate to that, and we'll discuss that as we go forward. The second was, how do these things relate to one another but become different? And from the beginning, we actually came up with the idea of the analogy of a chessboard. Any chessboard, its pieces look different. You can identify them immediately. The queen, the king, the pawns. But there's a visual language that identifies one chessboard from another. And we use that as an analogy to kind of think of how do we make things go together, but also be different. So to jump forward from images of master plan to at various points of completion, and these photos are gathered from several years of visits and documentation. But you can see how the residential towers in their courtyard relate to the street, the lane as we call it, really the public face of the project. You can see the one Lodha Place office building starting construction there, and the Supremus office building in the background, which was the first building that was completed. So just to orient you, SB Road, the avenue or the lane, Supremus office building, World Crest, you can see a little corner of World View, and World One is at the very left of the screen, and a piece of the clubhouse, which we'll talk about as we go forward. View from inside the residential complex, the entrance and turnaround. Back outside from the public park, looking across the lane towards the retail frontage, currently in this photograph under construction. Assemblage of images that show the pieces and parts of the building of the project. The 3 residential towers, they come down in the courtyard and make this very important threshold between public and private, the gateway. images of the towers themselves. The image at the left is a rendering. One of the key renderings we used to explain the project to the client and to the public before it was built, and quite satisfying to put it next to two photographs of the completed or almost completed project, in which the weaving of these strands really is evident. And you can see it in this photograph where there's a kind of basket weave pattern which animates and gives some energy to what's otherwise a very strong grid which reflects the structural system of the project. And the three images at the bottom are renderings which really showed how the living spaces and the balconies are integral to the architecture of the outside of the building. Transitions are slow, sorry. Another group of renderings on the bottom of the screen, showing our intentions and how these relationships worked in design, and 4 photographs at the top of the screen, which shows some of the same areas executed. So from left, the view from the lane through the gateway towards the towers. And the next is the clubhouse. The next is entrance to World Crest. And third is the view along the lane. Most satisfying to me, and this was interesting to see, these are photos from Instagram a couple weeks ago. Qualia, which is the great restaurant which occupies the space along the lane, took, I guess, probably maybe a year and a half after its existence to start using the street the way that we always hoped it would. And of course, they did this actually in response to the pandemic, to have outdoor space. But the canopy and the street, it's quite cosmopolitan. I think it's very successful. Finally, the last piece of this project is One Lodha Place, which is under construction right now. All of the work I've showed you so far in terms of facade is window wall and cladding. It's very low tech, very straightforward. There were some interesting extrusions along the way, but it's fairly uncomplicated in terms of how it's put together. One Lodha Place is a fully unitized curtain wall, incorporating metal, stone, glass, and you can see on the bottom of the page actually the mock-up. I think this was almost exactly a year ago. You can see Nitin in some of these photographs. I think this is a good transition to the part of the presentation, which I talk a little bit more about how facades came about. And I think that the theme of this, what I'd like to say about the translation of architectural ideas into reality and how do you get from A to Z in this particular project is, it's a huge project. There's a lot going on. And what we always were trying to do was to take something that has visual complexity and real interest, but actually make it as simple as possible to build and simple as possible to understand, foolproof in terms of its documentation. So the mock-up on this screen is an example of how we got there. But the series of slides I'll show you now, I'll run through them rather quickly because I think Nitin will go into more detail, is how our office developed our intent and understanding of facade in a way that could be enhanced and commented on and helped along by Nitin in his process to go from idea to actual building. So I'm actually just showing some photographs alongside drawings that we did to sort of understand the kind of thoroughness of documentation and thoroughness of thought and intention, so that ideas didn't get lost in translation and ideas were worked out well enough at the design stage, so that they didn't, fall apart as execution happened, or as the realities of how do you build this happens. The clubhouse, these are all renderings. Actually, so on the right are renderings, and the left is the photograph of the finished building. I should say that a couple of other facade consultants worked on some of these pieces, although Nitin has done most of the work. But the clubhouse was after the three towers was the next facade that we designed, and wanted to have a relationship, but also be different. So it has a material and color relationship. It has, again, this idea of fabric and textile, in this case, a kind of a linear fabric with a syncopated rhythm. It had some interesting geometry to it, some curves, and it had a lot of parts. And it has a kind of complexity to it initially, but it's actually made up. The screen will change. It's made up of a very discrete number of parts that repeat. In this case, I think there are maybe 4 or 5 panel types, which then get repeated and arrayed. And our drawings were quite explicit about kind of mapping the system and categorizing the system. Likewise, as we move to the facade that fronts the lane, of course, a very important and iconic facade, at the bottom is retail space and active nice things. But on top of that are 5 floors of parking and service, which needed ventilation and had sort of performative aspects. And so this was a major design exercise to figure out how do you create something that doesn't feel like it's the front of a garage, but actually feels like it's a performance worthy of the occasion of an important new street in Mumbai. This one, in a way, is the most explicitly like a fabric. It's a kind of tartan, and this facade is made up of repeating perforated panels, which look rather complex, but actually, again, sort of reduced down to a discrete number of panel types, which were developed through a parametric process. And the series of drawings you see on the page now kind of indicate the general idea of how it's constructed, the component parts, which were, I think, at the end of the day, 16 or 18 different panels, and then a kind of very rigorous mapping process about how they go on the building. There's a blow up of the panel type, so the type A through type G of perforations, and then how they combine in different ways. Very simple perforated aluminum panels, but with a twist. And then the kind of mapping. And for an architect, especially for a project this big, the most exciting thing is if they see it take on life of its own. So those photographs of Qualia in the restaurant are fun to see, and also from Instagram, Diwali about a week ago. That's all.
That was absolutely brilliant, Jay. I didn't know of the design inspiration and the fact that you took it from the mills that lay so close to the ground and put it up on these towers, which are going to be there for a very, very, very long time and continue as a fabric of life. Brilliant. Well done. Superb. So let's get on and see the technical side of the facades. So let me present my screen and show you what we've got. So hi, I'm going to take you through a little bit about Facet, a few of the projects we're working on currently, the Trump Towers in NCR and in Kolkata, 5-building project of commercial buildings in Hyderabad, a very interesting fabric-oriented, inspired facade in Rajasthan, um, another very interesting sort of feel of a facade in Qatar. And then our association with Jay. As Jay spoke about, we started our learning, our journey together quite some time ago. And this was the project that brought us together, the Wave Rock, the bar building, the first of the 2 buildings that were to be built. And so it was a brilliant, amazing experience working with the teams and turning out what we did. This is the top structure of Supremus, which is adjacent to the World Towers across the road. The Tower 4 and the World Towers visible behind. Another shot of Tower 4 that connects to the World Towers. And now finally, the World Towers, the focus of our discussion today. The inner engineering and performance inside out. And what I want to showcase here is what has happened, what has gone through the design of the facade, the technical design, and the thought process that pushed us in our line of thinking to do what we did. So here are the 3 buildings that you can see. And we started on one and then added on the next and then the next. That's how we were appointed on the project. All 3 are sort of similar, though the Queen Tower is different. It has a slightly different facade, but quite similar in nature. Now, when we started working on these buildings, we were told that the client would want to install or complete a floor every week or every 10 days. And the facade design should incorporate a manner or a facility in which the installation could be completed for a single floor in about a week, 10 days. So here are actual pictures of what's actually turned out. And it's interesting to note that we've got, though it only appears to be metal cladding and window wall systems and a simple railing, there's been a lot of engineering behind all of this. These are images from outside and inside, actual images of the work done. It's pretty neat, pretty clean, and amazingly durable, resilient to weather. They've been designed for different facades have been designed for up to 6.5 kilopascals of wind load. And so before I move on to the actual design, and forgive me, I don't have very good drawings to sort of project here. But what we did was we followed a unitized window walling system as well as a cladding system. So everything we did was unitized. So you could bring an outer frame, install the outer frame, then bring ready-made panels and take them to the respective floor, put them in position, and you're done. So an entire facade like this would get installed in hours. That's how quick it was supposed to be, and that's how quick it was designed to be installed. And it eventually did when they started installing this. I say this again, the picture quality is not so great. Unfortunately, I had a limited opportunity to pick up better quality drawings. But anyway, like I was saying, it was a unitized sort of system. So you can see an outer frame, a mullion that sort of inserts into the outer frame. This is the slider. The sliders, incidentally, have also been working to a very, very high wind pressure as well as air and water tightness. I keep hearing nowadays from many other companies that are, that where we need sliding systems to be designed, that they can't design them up to high pressures to perform against high pressures. And we always go back and say, look, we've done it, and we didn't just do it once, we did it 3 times, and 3 different contractors and 3 different systems were designed. So it's very, very doable. Don't need a lift and slide. A typical system would do. If you can see on the left over here where my pointer is, and there's some more imagery later, this is of the cladding system. Now, I'm sure you haven't seen a cladding system being installed in this manner, but again, it was done in a manner which was, panelized and implemented in a manner where you could do it in a unit format. The important thing in any building, in any civil structure, is construction tolerances. And these towers were no different. They were very, very large towers. And obviously there's lots and lots of concrete pouring, lots and lots of formwork and scaffolding. So you would expect some level of tolerance, building tolerance, which is concrete tolerance. And that's what we had here. So this picture sort of demonstrates, the ideal position, which is this picture right on top. And then the case where the concrete sort of bulges out and leaves you very little space, and how that would get constructed. And another case where the concrete would lean towards the other side, and you had a construction tolerance of 25 plus minus, and how that would be accommodated. And the entire philosophy of design on this project was around construction tolerance and how you manage construction tolerance, because that's one thing that would never hold you up from installing on the site, which was so critical. The system design, it had to sort of be segmented, faceted. So different strategies were used, where we had a typical sort of, we didn't have a typical mullion, but we developed new designs for the mullion and added further strengthening on the inside with these boxes. And everything was installed, as you can see, in a unitized format, where there was a panel from here to the next module. This was one module and this was the other module. On the left was the other module, and they came together beautifully and tested and performed really, really well. Another picture at the head level of the glazing system. Again, we had to accommodate or provide room for construction tolerances, which was ever so important. And there were many other structural constraints or design considerations in the structure that we had to consider, which included long-term creep, column shortening, movement of the building. Tall buildings do sway, so allow for all those movements, and at the same time make sure you get it installed really, really quick. So the installation had to be really simple, really fast, and very easy for the volume of work that needed to be achieved within a week. Same goes for the cladding. As you can see, there is the preliminary bracketing anchor system, and then you had a mullion sort of system every so often, and that connected to a hooking system for the actual panels. Another plan view of the cladding system. Again, I wish I had gotten you better pictures, but I think it gives you a gist of what was being done, how it was being done, and again, a unitized sort of format employed across the board. The railing systems were we're still on the cladding systems. And then here's a sort of horizontal detail, if you can see over here. Again, we have, it demonstrates how the units come together. They're open grooved, and then they allow ventilation as well as water drainage into a pressure equalized rain screen sort of system. These were edge sort of flashings, very key components in the design philosophy, the architectural design philosophy, and very important to actually bring in the balcony spaces and connect with the outside. You had the railings, you had the balconies, and then you had the outside cladding. To marry all of this was extremely critical and not such an easy task. But what made it happen quite easily was the method of design that was followed on how it would all go together and how all these pieces would work with each other and allow movements, allow tolerances to be accommodated, keep water out. So if you can see this flashing, this is the column, and this is a rain screen pressure equalized sort of cavity at the back, and any water which gets in here wouldn't come into the balcony space. There were drains that would allow water to go out down the panel. The railing system, again, a system where a strategy was employed, where there was a embed installed or a bracket installed, which allowed a further bracket with a rail. A ready-made system would come on the site, get bolted on, the glass would get bolted on, and there was no fabrication done on site, zero fabrication. In all the cases, there was zero fabrication done on site. I don't think we had any holes drilled on site as well. Everything was done in a factory and installed here. And that's about it as far as these projects are concerned. Again, whilst the look and feel was very simplistic, and I know a lot of people who've seen these buildings say, "Oh, it's only cladding," but I know the pains that the entire team went through to make this happen, to get this to be able to be built in the manner it was to be built. And I think it's turned out brilliantly. The basket weave has been amazing, amazing concept, and the engineering was one hell of an experience on this particular project. So yeah, that's that for now. Let's get back to our discussion. So it has been quite a journey on that project as well, and I remember when we were tendering out, I think it was World 1 as the first project, and we were tendering out. I remember, having our discussions with Mike where we were all very clear that it was going to be a unitized sort of format of construction, and we had contractors from all over the world. The biggest of the guys come to us, and some of them sort of said, no, it shouldn't be done as a unitized system. It should be done in this manner, that manner. It can't get done, that can't get done. And we said, no, it needs to follow the philosophy we have. And there's a reason why we want to follow the philosophy. And I'm glad we did. And we stuck our ground as far as that was concerned, and eventually proved it that it could be done, and not just be done. We did it 3 times over on 3 different towers with 3 different contractors with 3 different designs, which was is proof that when you put your mind to things and you put yourself behind it, things happen. You must believe in what you want to do. So it's been an amazing experience. These projects and developing designs of these projects. The facades have had their own sort of life, so to say.
Definitely.
Yeah.
I think I feel bad that during my part of the presentation I said certain things were simple, because of course they weren't. And the gray hair that I have, my hair got a lot grayer during this process than yours did. But I think this idea of simplicity and complexity, which in a way in these buildings go hand in hand, right? Building architecture of this scale is about how to take things that are innately complex and sort of seem undoable and breaking them down into their component parts. So, in the early design stages, it's how to systematize without making something, overbearing, and how to take that system and vary it and twist it, but also to know how you're, in our office, before you got your hands on it, as well, we had a strategy of how we thought this ought to be built, which was not too different from what you said when you came to it, and there were key things that you looked at. But what's amazing as I look at your presentation, even look at my presentation after having not spent a lot of time on this, is that in particular, like the graphics, the design graphics of World 1 executed are essentially what they were when we finished late stages of schematic design.
Mm-hmm.
There was strategy and approach, and you're right, we did stick with certain things that some people might have said, gee, we haven't done this here before.
Mm-hmm.
But the ability to fabricate and manufacture and test and understand things so that when they came to site, they could go on the building in an efficient and predictable way, it's key.
Yeah, absolutely. And I when you did mention that they were simple, I sort of agree in a certain sense, because cladding is simple, window walls are simple, but
85-story buildings aren't.
85-story buildings aren't.
And I think people go back. You made some comments when you were showing the sliders and those balconies.
Mm.
You and I have touched those doors
Yeah.
and slid them. It's sort of a beautiful thing.
Yep. Yeah. Yeah.
They're substantial quality items that will last forever.
Yes, absolutely. They last forever. They've been wonderfully built. The contractors have done a good job. The client was amazingly supportive to ensure that we get the highest of quality with zero compromise. So there was a lot that went behind there. There was a lot of sweat. There was a lot of toil to get it right, and there was conviction behind it, which made it happen. And made, curving panels is not the easiest thing. And it's not just curving these panels. Behind those panels, there were plenty of profiles which had to be curved as well. And everything had to fall in place right. So, and then you had the basket weave. So, whilst it looks so simple and so easy as a building, as a facade, the complexities were enormous. And I think the one thing that really worked well was the level of documentation was done, pre-construction, and because that was done so well thought through, the actual construction became a lot easier. That became simple compared to a situation if that weren't done. So, I think the like you said earlier as well, simplicity and complexity sort of go hand in hand, and you take complex thing and make them simple so that people see the simplicity at the outset. So and that's exactly what's happened on these projects. So it's been a wonderful experience.
Hello everyone, I'm Jinesh Gala, Director of TimexBond Industries. We are leading manufacturers of ACP and HPL in India, along with various different products like plywoods, veneers, laminates, doors, ceramic tiles. It is an honor for me to be here with these two geniuses of our industries and want to thank them both for sharing such precious knowledge in detail. So thank you very much for the same, sir. I have one question to ask. First of all, kudos for creating such an iconic project. It sure stands to be a landmark in city like Mumbai, and it will always be, I'm sure. Could you share some light on the choice of material used in the facade and why was it selected?
You want to go, Jay? Should I go?
I think I can certainly start because I guess I selected it before you did. I think for a project of this scale and complexity, ACP, a project of this scale and complexity in this context, right, needed to mix, as we've discussed, complexity and simplicity. And ACP was kind of the middleman for that in a way, right? That it could accomplish some of the complicated things we needed to do, but was, totally familiar to the people building it and the people occupying it, and flexible enough to achieve a lot of different things that we needed to achieve. People, when we were designing this, were wondering about it being stainless steel or metal. And the truth is, it's aluminum and it's painted aluminum, but the paints that we chose and the palette that we chose actually has a way of looking quite bright and crisp in its context, in combination with the design and the detailing.
Right. Perfect. Nitin, sir, would you like to share the answer for the same?
Sure. I think ACP offered a great amount of versatility. It was a product that was we chose a fire rated material so that we have, we, of course, across all our facades we use products that are fire rated, and the flexibility, the sizing, all of that sort of fell in place, and it was easier to work with compared with solid metal. It was coil coated, so we could fabricate, we could import sheets or get or procure sheets and fabricate it in India quite easily. And that was a big reason to sort of choose this material. Of course, there were lots of design considerations in terms of its ability to withstand, wind loads, cleaning BMU loads, etc. And so they needed stiffening and all of that, which is subsequently done. So that made that made the inherent nature and characteristic of ACP sort of lent itself and was a forerunner for this sort of installation.
Okay.
Yeah.
Perfect. Thank you so much for answering the question in detail. Thank you. And it is an honor to be among both of you.
Thank you all.
Our next session and the last for today brings us to this invigorating panel discussion on facade design, collaborating to engineer the impossible. This panel gives us an insight on how architects, consultants, and contractors work in tandem with one another to create iconic structures through design and engineering. This panel is being led by architect Ravindra Kumar and will also have on it architect Arunjot Singh Balla, Mr. Tilak Thomas, Ms. Gayatri Kapur, Mr. Jinesh Gala, and Mr. Anwar Ahmed Mir, each of them bringing in their respective perspectives from their experience.
So, good evening, ladies and gentlemen, and it's fantastic to be back to host another discussion for iDAC. It's always been an opportunity for me to sit on the other side of the table and answer a few questions. So when iDAC invited me, I thought I will provoke some answers from some of the most super leading architects of the country and who have built internationally, done spectacular facilities. We have Arunjot from RSP, Tilak from Thomas Associates. We have Gayatri Kapur from Vistara. Who's also been one of the largest contractual sort of leads to the country before. We have Anwar Ahmed Mir. He's also a glazing contractor coming from Germany and India. So we thought we'll try and bring this panel to a discussion where also we include Jinesh, Gala and Anwar as representations from supply vertical sequence. So let me get on with the first posture. Many years back when I was in Venice, there was this whole question on a panel discussion whether Zaha wants to be Gaga. It was a position where an architect aspires to build something spectacular, which sort of walks through his mind and his imagination. And he does include the client, but most of the time it's a didactic posture. So will a curtain wall enhance my business from a customer perspective is also something that we need to understand from the tropical world. So I request every panelist to reciprocate as what they think. It's a discussion.
I think before we start with the discussion, I would like to chip in. When we talk about curtain wall, so we are assuming it's covering a building. It's an envelope. I wouldn't take it as a curtain wall because curtain wall can be anything, right? So I'll take it in a broader sense as an envelope on a building or anything else. It can be a wall or it can be a rain screen, either of the two. So we should put our direction in that. Basically, how do we want to clad our building? So curtain wall is just one item. It's like you're putting a curtain on the building. That's it. But envelope can be broader.
Completely.
Yeah, so I thought that for the purpose of discussion today, we stay with a focused, yes, it's an envelope, but stay with the structural glazing aspect, if that is fine by everyone, considering the time constraint. So we can focus on the fact that the curtain or the external envelope stays somewhat disassociated from the main structure and seen as a sheet around the building. And I think that is what we can possibly focus on in the 30-40 minutes we have here. Though you are absolutely right.
But this is what I have been talking for many years. People get confused between structural glazing and envelope, right?
Yeah.
Envelope. Structural glazing is just a method of cladding a building. It's nothing else. Anything what you put on the building is an envelope.
I agree with you, but just the idea of an envelope becomes extremely very large at the gamut for introspection. So I would align pinch more with Arunjot to restrict the discussion for a glass envelope. Let's say it's more associated with that rather than going into many materials.
Okay.
So,
All right.
so I posed the question to Arunjot. Do you sometimes introspect the idea of what you want to do as primary, or how does that work when you design these superb, structures?
So Ravi, it's interesting, but I'll just back up to Gaga, and you were clarifying a little bit earlier that Gaga was the awards, and I was thinking Lady Gaga, so. And I thought Zaha wants to be the fashionista of the architectural world. God bless her soul, she's passed on and done some seriously fantastic work. But it's interesting. See, a business is, and I'll leave the business question a little bit out of the window for a minute. The clients coming in and saying what kind of curtain wall or what kind of structural glazing can we get, and this desire to do it. I've been 2 decades now in Bangalore, and we were probably the first one at the IT park in Whitefield. And that kind of spawned a revolution of sorts. Every possible client saying, why can't I have this shiny glass facade? So from a business perspective, it was thought that if you had a nice shiny facade on the building, that is contemporary, that is what is going to be the Gaga element in that particular building, if I can say that. And clients were very keen to get that aspect. We did ITPL, but that had spandrel panels which were in aluminium. We had regular glass in the vision panels, and then went on to do many more as much as Ravi, you did, Tilak did, other architects in the city did. And then we had the reverse happening. And since I myself said we will not get into a larger envelope discussion, but we had a kind of a pushback saying that, oh, there's too much glass on buildings, so on and so forth. So while architects look at getting a seamless expression, some clean lines and facade treatment through this particular medium, the business aspect looks at what is going to do a sale. What is the current trend? Is it a lot of glass? Is it no glass? And we as architects get this push from clients saying, listen, now everything is glass and I don't want glass. And earlier days it was, well, why can I not get that shiny bit of glass? Waxes and rings, and as we will discuss today, the pros and cons, it has some serious good benefits, it has some great form benefits, it has great function benefits. I'll just pass it on to Tilak to add further on this. And Ravi, though you're moderating it as an architect and done tons of work here, I think you should chip in as well and say your opinion.
Yeah, so I'm understanding this question a little differently. I think, are you asking us if we design to win awards, or if we design to, or we design for the client to make some money? So I would say it's an sorry.
You were on mute, Ravi.
It's almost a metaphor. I don't know whether you want to be Gaga or you want to win awards or you want to.
Yeah. So it's an aspirational thing, actually.
I would like to step in here. It's like, that's where we innovate. You want to be Gaga, and we as system suppliers or contractors, we want to bring down the cost so that you're able to achieve it. That's where the whole innovation stands in between.
Yeah, I would say it starts with the whole list of aspirations, right? So the architect has a set list of things that he targets to do. The client comes in. Like Arun was talking about, back in the day, 20 years ago, there was this, move towards glass means, Gaga and things like that. But it has evolved, it has matured quite a bit. It's a matter of balancing all that out, right? But bringing all those aspects together and putting in the right mix. It doesn't mean that the use of more glass will bring you more money or more returns from the project or anything like that. But really, being able to balance out everyone's requirements and the functionality of the building, putting it together, and delivering it that way. So it's, that will probably bring you more awards than more of a. I mean, Zaha herself, if you look at it, a lot of the buildings, most impractical. I mean, fantastically designed, fantastic award-winning structures, but I mean, God help the users.
One thing is for sure, Tilak, between yourself, us, Ravi here, I'm sure Gayatri as well, we are either guilty or can be held accountable for adding a lot of silicon into the Silicon Valley of India.
Sure.
I'm trying to do that less now, Arun. So I don't, but I agree with you. But when you came as an international practice, and of course with your own sort of super capability, Arun, how much was that essential to use glass walling systems? What was that?
So I'll tell you one reaction that I had, and it's good you asked that. So I had spent some considerable time outside the country and was coming back in, was fairly, frankly, quite appalled by the plaster quality and the concreting quality that I saw those days. And the glass envelope coming in out of the building literally became a savior, because whatever were the imperfections behind got covered with this nice shiny envelope. And I'm not. So my first reaction was that it's great. It's more from the standpoint of that you have something that is not looking really great as it is getting executed, but then you have this sheath that comes and envelopes it, and that was the first immediate reaction. Now, as we developed and we understand, Bangalore is a forgiving climate. God forbid if this whole thing had started off in some of the cities, maybe in Gurgaon, and Gurgaon became literally later a totally wrong place to do that much of glass that got done there. But Bangalore was forgiving, and Bangalore climate enabled us to explore this material, and all of us then went to town with it. So the immediate reaction was, this is a savior. As work progress, got better ideas of how it can be a nice skin, how it can be sustainable, what are the other attributes it brings. The fact that it came prefabricated in panels, it just transformed the entire building industry. I must say that from a set of buildings that started happening in Bangalore, and then went to some parts where it was not very appropriate, but in large areas, it really brought the next step as far as the Indian construction industry was concerned of getting prefabrication. Every time anybody says prefabrication, we conveniently forget that the skin that we use the most is the first prefabricated element that has been there for decades now. We start thinking of columns and slabs and so on and so forth, the structural elements, but the glass facade has been prefabricated and has transformed the Indian building industry completely.
I think what you say is absolutely accurate, and there's this huge shift that happened over the years. Tilak, your practice has been sort of the origin of many innovation ideas for the city and south of India. You and your father, my biggest reverence to him, because he's been such a jolt to change the way the city sort of looked at buildings. He's been the Batman, to make Gotham happen here for the South. And is spectacular as a persona and as a person with capabilities. So where do you think the whole system of a glass envelope sort of helped or did not help, or your reciprocation to it for buildings?
I mean, we've reached a point where literally we are seeing pre-COVID days where, because of timelines, we were seeing that civil contractors were saying add more glass. And glazing contractors telling us, add more block work. So that they push the workload onto each other. But rightly, like Arun said, it transformed buildings from being literally head load, putting things on site, pouring it on site, to factory built, factory finished, where you have some control on quality, timelines, all that. So it is moving in that direction. It can be panelized, prefabricated in anything. I mean, whatever the material that you use is, not relevant, but it's really the process in which it gets built. So yes, we have seen from back then, we have seen that the market has slowly changed. It's over. The days of it being, gimmicky, and those days are over. So now you got to be realistic about how you use it. Clients are much more aware. End users are much more aware of how the effects of what that could do to your AC loads or your lighting daylight conditions internally, things like that. So there is a lot of room for innovation. There is, I would say the fact that we work in a very low end economy where cost of construction is something like, I don't know, $18, $20 to $30 a square foot. It's a challenge, and that poses a great, a great room for innovation. How do we make it all work within that, right? So in that $30 a square foot, I don't know what the glazing cost comes down to, some, I don't know, $1 or something a square foot, So we're not, not $1, a little more than that, but we have to make it all work within that. So that really pushes this innovation. And that way, Bangalore's been, the weather being the way it has allowed us to do a lot of play with a lot of forms, try out different finishes, try out different materials that we can use on the exterior, and then really refine that to take it forward to other cities. So the city being as cosmopolitan as it has been allows and accepts a lot to pushing cutting edge design. As I understand, even fashion brands launch their fashions here first, to try and gauge the market and see what it can do. So, yeah, it gives us a lot of opportunity. I think we are pushing that envelope. Jointly, I think all three of us, cover a huge percentage of that. So we're pushing that envelope as it goes. On the leading edge, not bleeding edge, as I always like to say. So Gayatri, anything to add to this?
No, I agree that, as the curtain walls on buildings have evolved over the last 2 decades, there's been a huge shift from it being initially gimmickry, and, at some points we were just shown images and said, okay, that's what's done the world over, and can you do that and deliver that for us here? To today, there being a much more conscious debate as to what kind of material is used, how it's applied. And I think there's a greater appreciation for the technology that comes with curtain wall today. Although pricing has, I think, remained pretty constant. I think maybe from $1.50 a square foot, we've gone up to people being, very generous and allowing us maybe $2 a square foot, but it's still pretty low. But more or less, I would say that the industry has evolved pretty well, and it does have a great future. I do agree with Anwar that you have to consider envelopes as envelopes and not just curtain walls, because there's so much more that we do to the buildings, that you all do to the buildings, that we are then asked to detail out and deliver on, which goes much beyond just glass. So
there's another thing that I must add here. You used the word appreciation. So every market, and the Indian market at large, and Bangalore in particular, has benefited from international corporates coming in. Now, they brought in a few things. And if we take this whole discussion to another level and stop thinking for 1 minute glass, and though I said we will stay focused, go back to Anwar's idea of envelope. The word that is in my head is light. So this appreciation of getting natural light into the building, I've seen, particularly in Bangalore, has been just increasing. We've seen it year after year. I remember the battles we used to fight with various clients, and including the fire authorities, on having buildings with a central core, and were repeatedly shot down. Ultimately, one building got approved, and then fire authority got comfortable. But the entire envelope and the glazing and the glass that brings on the outside of the envelope into the building the amount of light. And now, happily, clients are, even in residentials, are okay with glass going from literally from the skirting level right to the top, the expanse of space that opens up. So these things is a qualitative aspect which has enabled us to do what we are doing. Buildings are no longer just going by that word Gala seen from the outside. It's the experience on the inside, and if the experience on the inside is qualitatively different when you get floor-to-ceiling glass, and which it is, then there is greater receptivity all around. Some of the newer projects, even on the residential side, some criticism is, oh, are you designing a residence or are you designing an office? It's all blending, but it's also this internationalism, this aspiration to have more and more what is happening outside in the country. It's a whole globe coming together. One sees microcosm of that happening here, which I see as very positive. Sometimes the criticism is, well, then where did the Indian aspect go? But that's I think, a little counterproductive. When you have a technology, when you have good materials, why not use them to have the right expression? And if you are comfortable with everything else, which is technology-wise coming in from the West, why are we fighting this bit about having expanses of glass on our buildings? So it's a debate that cuts both ways. But I think the light, the natural light that comes in now into buildings is fantastic.
Yeah, I would like to add here, looking at, we always say that we build glass boxes on the buildings, but the world towards double skin now. You don't have single skin on the buildings anymore. And what we start is, when we start designing a facade, we start thinking from interiors, not from exteriors. We know architects have aspirations. We know the clients have aspirations. We know that people want the buildings to look nice. So basically, we start from interiors, not from exteriors. First thing we look at is the load. That's the HVAC load, that energy load on the building. Now, you have a cost, which is energy costs. Then you have an envelope cost. If you can balance those costs, you reduce the cost of energy from inside and put that on the envelope, right? One, your envelope looks better, plus your building is performing far better without many number of parts which are functional and you don't need regular maintenance on them. So the world is moving towards that. Like, for example, some buildings don't have air conditioning anymore. The two skins on the outside of the building work as an air conditioner curtain on the outside of the building. So I think that's where the world is moving. And on innovating, when I look at building systems or the systems which put the glass together, 3D printing has changed the whole dimension. Now you can print your facade. It's like, even if you're printing like a 20-meter wide panel by, say, 20-meter panel, you can print it. Just bring it to the site. You don't need technical people to install it. Just a drawing which speaks a universal language. You have a couple of guys coming in installing it with a crane. So the world is moving. It's a long debate. We have to keep on innovating. We have to think from inside to outside, not from outside to inside.
Very impressive, Anwar. Absolutely accurate. In fact, Anwar and I worked together on a project for Cummins in Pune. We built the world's largest secondary walling system. It has a Guinness Book of World Record. So Anwar was the lead engineer doing the structure, which was for the India Technology Center, where we have 60 test cell laboratories built for Cummins, which was a spectacular experience learning from Anwar. So very well said. What do you think is the need for legislation? For example, for a curtain wall, or for the external envelope that would sort of modify the nature of the premises in its surrounding. Gayatri, I'll pose this question to you. What must be the nature of legislation for architectural sort of articulation? If we have to define what should be that, the external envelope or the curtain wall. Should sustainability be the only agenda, or should there be more parameters of interest that should format that idea? Gayatri is being like a mother god, in our occupation, because she's been an architect first, then she's been one of the biggest contractors, heading one of the leading contractual companies. Now she's leading one of the largest consulting companies for doing glazing systems. I think she's been a bit of all. It's like having 10 hands, So Gayatri, over to you.
You're always too kind, Ravi. But I would say that, you see, the NBC has already started taking steps in that direction, where they have started defining sustainability, fire safety, the use of glass in buildings. A lot of it, of course, is still copy-paste from the codes and standards across the world, which is not a bad thing. It's better to get a head start somewhere. But I don't think that you can really define or legislate creativity. And buildings are going to continue to be different. I mean, you have to respond to the nature of the building, the client's brief, the site itself. So there's so much beyond, there's so many, I would say, immeasurable parameters there. And I think that what we have right now in terms of the NBC guidelines is a good start. I don't think you can legislate beyond this. You will otherwise start feeding your creativity.
Yeah, I'll add to what Gayatri said. She's absolutely bang on with what she said. It's like when we go with the code books, your engineering judgment is defeated, because there are certain codes which are so outdated on the NBCC that you cannot use your engineering judgment and optimize the amount of metal you're using on the building, or the thickness of the glass you need on the building. It's just pushing you to spend more and more just for nothing, when your engineering judgment says you can live at least with 30% less material. And if we look at particularly India, what Mr. Arunjot said is like, Mr. Thomas said is that we use a very little amount of money on the building. Is the 70% cost of construction of envelopes in India is material, and 30% is the labor cost, where in Europe it's reversed. your material cost is only 70% and 30% and installation 70. In India, we have to be innovative, right? To work on reducing the cost of the materials, and the codes come and they step into you, which they don't allow you to use your engineering judgment. Like, I'll give an example. When I did my first cable net wall in India, that was in Delhi for ONGC. And, we had to design the cable net wall, and the deflection limits what we use in Europe for the cable wall are L over 50. And suddenly I get a code book which says you have to design your cable for L over 240. So going from a 50 millimeter cable, I had to use a 300 millimeter cable, which I couldn't do. It was basically, throwing a lot of money into sea. But at some point we had to break our heads with the people and, tell them we have to defy codes. We had to demonstrate that this cable works at this deflection. And that's the biggest challenge, I see in the Indian market, unless and until we are not able to change that mentality of defying the codes and using engineering judgment, we cannot get any better on the costs.
Jinesh, I ask you for your reciprocation. When you do products, how much is legislation important?
Sir, I personally believe there should be a perfect law that guides us on what products or standards that every manufacturer should keep in mind or set for themselves. Unfortunately, particularly to products like ACP or HPL, there isn't one. But on a practical side of it, I'm really happy to say that in today's time in India, every good project is using FR grade ACPs or HPL. And we are currently supplying only FR grade ACPs of class B standard. And now the entire industry is moving towards class A2 grade ACP. And we are in development stage of that. And we are also into certification of all these products. So legislation is no doubt, whenever I meet some good consultants, fire consultants, and they ask me, why do you want to certify this product for India or for outside? Because outside the laws are different. And you will be needing some of the certificates from us, which is currently not required in India. So legislation will benefit everyone one day, and I'm sure it will happen sooner or later. But even without the legislation, I feel due to some mishaps because of the fire, the use of particularly fire FR grade products for facade is pushed by you all and other facade consultants. And we are happy for that because we are getting to supply some really great quality products in the market.
And after some disasters that happened in Dubai, Singapore, and some countries like even Middle East have started thinking not to use ACP. What do you think of that, Jinesh?
Especially in UK. After a big fire in London, they stopped using.
I personally believe that some things cannot be ignored. Obviously, I cannot comment on the preferences of any individual, but ACP till date is doing great, and the future of the product is also intact because we are into some really, before the discussion we had mentioned that this time is for R&D, and we are really working on some great designs also. So I feel, give or take still, even if we talk about UAE, the most used product is ACP over there. But no wonder they use the A2 grade ACP, which is expensive, but it is really helpful in case of fire. And now India is moving towards A2 grade products. And so product will remain there. And we are also working on introducing more products, more different products. The R&D is always going on.
Arun, what do you think legislation means to you? Many years back, I was interviewed for one project when Charles Correa was the head of Urban Arts Commission, Delhi. I used to go present my schematics. This is not many years ago. And of course, after he signed off on the project, we became the best of friends. I was his chauffeur every time he came to Bangalore. But it's interesting that design can be also qualified. Do you agree to it? Or what do you think should happen? How would you respond to that, Arun?
Before I go there, it's interesting to hear that you were a chauffeur for him, and I used to make coffee for him when he used to be in Boston. So there's something that now see. So now you bring that Urban Arts Commission. It's more on the aesthetics of things that you are alluding to, and between Gayatri, Anwar, and Jinesh here, they have literally said from a statutory standpoint what the codes are, and the codes continue to improve. The shocker for me actually was the London fire, because like Gayatri said, many of the NBC are takeoffs from other codes that might be at very high standards on the planet. So it's a continuous improvement. Now, when one looks at codes, one has to look at it in a proactive manner. And the reaction that was coming in my head was that, see, typically when structural glazings are happening in Europe and other places, we do not really have that many openable elements in the outer envelope. In Bangalore, as all of us who practice here know, that there are a certain number of windows that have to be kept openable, even for exhausting smoke or so on and so forth, as it is called. But during the COVID time, as we tried to open our office, there was a big situation which said people do not want to have the central air conditioning running in the office. I was keen that the office should be fully operational. People did not want air conditioning. We were struggling to have the fresh air cycle running just on fresh air, and whatever filters coming out of Bombay were not reaching here. Which led me to think that there should be some legislation, or if it's not legislation, there should be some abilities to have more openable or apertures in a very seamless manner in the envelopes that we design. And not only this, the top hung systems that we have. So coming back to your question, from a statutory code standpoint, I think all three of them have spoken well, and that's what it is all about. But from an actual operational thing, if it is a true skin, then apertures that open in the skin in a cost-efficient manner is something that we need to innovate and enable so that there can be some percolation of fresh air. This is the thought that we actually started facing it in our office during COVID.
Tilak, any reactions?
Yeah,
I think that's more to Anwar and Jinesh. What do you think? What can we do, and how do we do within
And that's what I said. The whole world is moving towards double skin now. You know, it's been more than half a decade where it's moved towards double skin. Nobody, ideally, technically, I think 60% of the market has moved out of single skin buildings. They are not in vogue anymore. So double skins, primary skin will be a weather skin, which attaches to the building. Then you have a secondary skin, which is functional towards weather. But in the sense is, you're looking at reducing the HVAC loads, shading coefficients, and then,
we'll catch up offline. It's vast subject. I'm actually talking of air movement and cross ventilation. So we'll catch up offline one of these days when we are all getting over a cup of coffee or something. It's something that I'm very keen to explore with innovative minds like yours.
If I look at low-rise buildings, it's not a challenge. But when it's a high-rise building, if you're opening up a window at say like the amount of wind load you're coming in is so high, you might actually get blown away.
It was a lot of drama. It was a lot of fun inside. Just activate the space like that.
the new technologies are there where you can have certain elements in your spandrels which are breathing constantly every 30 seconds.
Constant ventilation.
So you don't need
to taking this is there's a project that a company has done in Singapore. It's called the Capital Beams, which funnels in, and Toyo Ito, I think, was the concept architect, and he had some great innovation of how he brings in from the terrace, funnels in all the natural air and so on and so forth across the skin and into the building. So I think, like I said, too short a time in this, but I'm not really thinking legislation. I'm thinking further innovation in terms of making this outer skin also breathable and also having the wind movement and air movement possible. Without taking recourse at all to air conditioning.
So a lot of passive methods must be explored.
Yes,
can be done. Tilak, in your experience, I think your practice has been one of the super senior group of architects out of the city. Out of historicity, have you seen any shift, or in terms of the parameters of design and your reciprocations to the fundamentals of legislation? How do you see all that happening?
Yeah, sure. So as we continue to innovate, all of us continue to innovate, legislation is a very key part of that. It's seen from other disasters or calamities that happen around the world. So we are luckily in a position where we are in that nascent phase where we can learn from others' mistakes. So natural or man-made disasters. So recently, like say in Beirut, when that in Lebanon, when that bomb blast happened, what is quite apparent from all the videos that you see is the amount of glass that was there, and the amount of implosion of glass into, and most of the damage that you see to people's faces is glass prone. I mean, glass, created by the glass that existed. So then comes the question: how come in a country which is so prone to bomb blasts, you have that extensive use of glass? So legislation does play a huge role. Or if you see a fire, or if you see a tornado, I think we had some tornado in Chennai a couple of years ago, and you could see panes of glass falling off the buildings. So it was like, it starts scaring you. Yes, we are putting a lot of glass onto buildings, but then sitting back and thinking, what if something does happen? How does that? So legislation can set a broad guideline. It doesn't have to restrict design. It could set a broad parameter into which we could all fit. Arun had mentioned this whole fire thing over here of how many openables. It's anyone's question. If I ask, all three of us have different answers on what the rule says, because the rule is that way. The rule is that way that we interpret it the way we feel right for the experience. So,
but Tilak, you guys have, I know this, and you work for Israeli-based companies and have extensive experience on handling the impact of bomb blast on facades and so on and so forth. I know that because the RFP called out for that. Yes. And backing up to another point, Ravi and I have a common client who, when we started working earlier, he puts ceiling fans in office spaces, and I used to think, what the hell is that? But that's got to do with radiant cooling. But I was remembering them very fondly during these COVID times in the office that what a blessing to just put on a ceiling fan. Nothing to do with envelopes per se, but simple solutions. As we try to do modern things, I think we have to keep ourselves anchored in the earlier simple solutions as well and see how they can benefit. Yes, legislation will continue to change, new challenges will come up, and more will get added. But what we have currently is pretty robust, including fire-rated ACP. To go to Jinesh's point, AC is not totally out. ACP, a lot of clients that don't do it, but it's not totally out of the window. Fire-rated ACP is coming and it's doing well. It's okay. We don't want a palette to be restricted as architects. We need a great palette, and we continue to work with it and enjoy it. And I think that's what it should be.
Legislation at every stage of the job, Arun. So it's at design, at execution, post-completion, into some sort of inspection phase, because very often what we design is not what is executed, and we don't have control over.
I agree with
very, very, very often.
We don't have control.
You're right. Legislation when it comes goes beyond design. So the NBC gives you your design legislation, but beyond that into execution, there is no code, there is no compliance, there is no certification as to who is valid to be. Whether he's a material supplier normally gets his validity from the processes and the product he's manufacturing, and there's some sort of testing which happens. But when it comes to contractors, fabricators, they are just assimilators of all the materials which come in, and there is a gap. Like you mentioned, what happened in Chennai. Now, it's not that using glass on the facade was wrong, but it's the way it was actually. Possibly it may have even been designed right, but how did it get implemented? So unless there's going to be very stringent third-party auditing of the process of installation, you're never going to be able to fix that. And I'm not sure, I think while the market is starting to get ready to recognize that even as consultants, that we have a larger role to play beyond that of just design consultancy. I think we're slowly getting towards that, but we're a long way from where we should be, that everything would be properly inspected and regulated at the job site.
Okay, I would like to add here, if you're buying a small product, normally you will see specs laid down by the manufacturer.
Yes.
Responsibility of installation is with the people who are installed. They should be certifying what they've installed, right? You can have third-party certification later on, but somebody has to write down the specs for installation. And that comes from the product manufacturer. And then you have to trickle it back to NBCC, go get it approved if you want it to go on a mass scale, but primary responsibility would lie with the installer to write down the specs for installation.
Anwar, very often it is a whole lot of materials that have been certified, but then the system that puts it together. So
I'm not talking about the materials. I'm talking about the installation part. Yeah. I'm talking about the installer has to lay down specs for the installation.
Sure.
Arun?
I think, yeah, they've made a start, but it's a long way.
So when you say a fire-rated, FR-rated, ACP panel, how is it fixed? Because the panel itself may be fire-rated, but is the framework, can it withstand that kind of,
What we are alluding to also is, we are restricting ourselves to glass and ACP and some metal, but now, of course, in facades, in the unitized system, granites and stones can all be incorporated. Some legislation around what the structure should do and how the structural integrity should be looked at and be regulated so that it's all compliant with seismic loads and so on and so forth. So the list can be quite a bit, but I like Anwar's answer that there is somebody underwriting it. So that the individual kit of parts, and when they come out, so the individual kit of parts have to have their specs and integrity, and when it all comes together, the installer has to kind of sign it off, and then the roles that the professional team has, Gayatri, you mentioned right to the end of the project and sign up and handing over. If it gets tightened up, you get better products. It also brings a kind of a vigilance on the system at the manufacturing stage, installation stage, and the delivery stage, and all of that will help, for sure will help.
I'll give an example. Recently, Dow has started. If you have to silicone a joint in field, you need to have certification from Dow, and the person has to be there all the time. It's a lot. Unless and until Dow has not certified the installation, you cannot pass your certificate to the owners. So it's teamwork from the suppliers who lay down the specs for the materials and how you install them. Then they come and check, and once they check, then only you can pass on your certification to the client. It's very important when you're contracting in a contracting business, you adhere strictly to the specifications of the manufacturers, right? And that's where I said installers have to write the specs, pass it on to the clients, sign them off, and stick to them.
That's the ideal world. Definitely, we would love to do that. And it's good to hear from also Biden that he wants to increase the minimum wage, labor wage in the United States. I don't think this country will ever stare at something like that.
Yeah, like in Europe, we have come out with a curtain wall system now where we don't need any scaffold from outside. We don't need any swings. We install everything from inside, right from metal to spandrel panels. And if your spandrel panel is breaking, you can actually change it from inside over a period of time. So you some cleaning system from outside to clean your buildings. Let it be 1 floor or 100 floors. Now the systems are all inside from inside, installed from inside. Nothing is needed from outside.
Arunjot, if you're given a magic wand and you're allowed to do whatever you want, what would be that innovation idea that you would do for glass technology?
See, the question is so interestingly put. And any answer that I will give now is going to look very less, compared to the way the question is worded. So, magic wand or no magic wand, I think first of all we have to literally admire the strides that the industry has made over time and been such a big boon. Just imagine, just forget for 1 minute the Chicago and New York skylines. You really would not have had the other wonderful skyscrapers on the planet without this magic system on the outside of the skin. If I had a magic wand, what would I want to do? I would want to do a bunch of things, but the top of the agenda is what I keep going back to it. How can the system be more breathable? How can the system be more akin skin-like? So I'm not even talking of form. That's left to the imagination of all architects and designers. I am talking more from a performing system beyond the double glazing that you are talking of, Anwar. How can it be a true skin to a building, and what all does it do? I know it's going to open up a whole set of discussions, but that's where my mind is.
What's the most super intelligent system of curtain walling that you've done? I mean, till date, out of your experience, where do you think you saw joy?
Me?
So you're asking Anwar, you're asking Anwar, right?
Arun.
Okay, to me, I must tell you, it's been a little bit of a sad story, because every time we have tried to bring in systems that respond to, for example, louvers and movable systems on the outside that respond to sun movement and are more climate responsive, it gets beaten down, Ravi, at the costing stage, or it gets beaten down at the tender stage. So pretty much, if it's restricted to the Indian setup, it's not been successful. So it's not been, we don't have a single movable facade of the real nature responding to climate. We haven't done it. Do we aspire to do it every single time we try very hard? We just get beaten down. And dust is the other one. The other issue that always comes up is that if we had moving parts, how will we handle the dusty conditions in India? So the answer is zilch, boss.
Tilak, you've given a magic wand.
Yeah.
Zoom, I look like Aladdin, half Aladdin, you know. Not
You know
able
what?
to make it happen.
What I've done recently is, you know, let me come back to double skins. They don't get very expensive. If you have a weather wall, then you use perforated panels on the exteriors, which give you like 50% light coming into the building, and they're like just 300 millimeter away from the building. And you know, they work wonderful in terms of, you know, shading, and you can clean them with water jet. Like, you know, Arunjot said they have a problem of maintenance of
I am dreaming with my magic wand of something that is automatic, that is so responsive, things move, things change. You see, it's very exciting. The facade is dynamic. We haven't been able to achieve it. We came very close in one particular project.
I think I'll add here is the world is moving towards 3D printed facades now. It's going to be for just 5 years. You'll see the influx of printed facades in India as well. There'll be no more factories. The factories will be redundant in period of 5 to 10 years.
Anwar, you came with so many fantastic ideas, and I don't know whether you recall this huge mega project that we were doing together. And by the time it got implemented, it was an apology of all that we were dreaming. So on the realistic sense, let's keep that on another day, another session, yeah?
That's what
yeah. On a realistic sense, like, you know, we were talking about having explosions, bomb explosions, and the materials to be used, which can be, I think on one of your projects, Arun, that's on Prestige Shanti Niketan, we used an ETF skylight, you know, not a skylight, but we used an ETF canopy, which was a new material into the country.
It's still there.
and that
it was
material,
fun. He set up these mock-ups, you know. This Anwar came and he set up these bloody blooming disco lights there, and they were it was nice, very, very nice. But I must say that he really pushed hard, and we have this set of canopies that go literally the extent with the length. Anwar is as much as Brigade Road. Wow. And lit up in the night, it's really beautiful. So you are right, absolutely, on that particular project.
It's safe. If there's explosion, there's fire, there are no falling debris from the canopies. Yeah. It's safe.
So we realize that innovation comes, you know, baby steps at a time. We can't. We've like what Arun was describing. If you take too big a leap, you're pushed back heavily to this thing. So you can push it forward gradually. Each project you push it forward a little bit, where your clients don't realize you just made some great innovation. You push it forward, you're happy, things will move forward, and you.
And I think it's everybody's wish to mass produce on a lower cost and have the facade what an architect wants, you know. And I think
a very interesting project recently where the entire building, I mean, client-driven requirement, not really. So that's where it comes in, where the client, contractor, everything comes together. The whole team comes together, where they wanted it manufactured in the factory. The entire building of about 900,000 square feet was built in a factory,
wow,
assembled on site, you know, top down, assembled on site, on site. So that would call for a lot of innovation. How does it work when you lift an entire fitted out floor plate with all interiors, with everything built in, lifted up to the 9th floor and then start from there down? It called for fantastic amount of innovation. One off, I think, we got to work on it, luckily, whatever. We got to learn a lot on that. Technology played a huge role. The fact that it was a collaborative effort and not that people were sitting on different sides of the table really pushed that project forward. So that's possibly a new way of looking forward. You know, so
I think it's always collaboration between an architect, between the owners, between the contractors, between the suppliers, which make these kind of projects happen. But if it's a regular project which is going out for a tender, too many bidders, there's no collaboration, then they don't work. Absolutely no. It's like you'll be building 100 projects a year, maybe one gets successful in a tender, but if it's collaboration, they'll definitely work because everybody's on the same page then. And in innovation, you might go wrong also, you know, at times doing small parts, but you overcome them because you keep on innovating. And if there's no collaboration, they'll never work.
Fine, please.
So, Gayatri, sometimes, you know, when I post that question, of the magic wand. When I introspect, I think sometimes you don't need glass unless it's bringing light into a building for the tropical world. Why would you ever want to use glass in any other surface which does not bring light into the building? Because it has more adverse effect that it can provoke in its proximity for its surroundings and everything else as the heat island sort of accentuation methods. So what is your reaction? What do you think, not as a point of legislation, as a point of design and as a point of an ability to change something, if you want to redo a system design, as also a consultant today, what would you think you would want to do?
So I think the nominal use of glass is the way the buildings are progressing. I don't think we're doing indiscriminate use of glass in any case. So it's a very judicious mix of various materials that is going in. We're gone past the time when it was just a glass box, irrespective of what it was being used just to clad a building, irrespective of what was behind that. So I do think that we are already at that point. I think maybe if we were having this discussion 10 years ago, it would have been different. And we would have been saying, you know, this is the reason why we should use glass or we shouldn't. But I think whatever infill material is used into the system, I think it's important to have the engineering right of the system. And the system has to be able to relate to the main structure. And I do believe, I do endorse what Anwar says, that sometimes things get over-designed unrealistically, which adds to cost. And that cost could very well be put into the use of a different type of material or enhancing the materials that are used. So a collaborative effort at that stage will help you get your creativity where the clients don't push back, if we're all in on the project early enough. But I don't think we today are looking at buildings which is just glass for the sake of using glass.
Arun, when we deal with many clients, such as, for example, Salarpuria or X, Y, and Z, you always get to hear from them it's easier to do glass than masonry and plaster and paint them or clad them. You know, most of the time, obviously the cost reasons also today is sort of weaning towards the idea that just doing a single glass facade or a double glazed facade is the most cost effective idea than doing a wall and cladding with, you know, something more expensive. So what do you think when you do, be honest, do you do it from inside out or outside in? And what do you think should be done?
So there are categories of clients, right? So some are very clear. When you look at what I call the international corporates coming in, which is a big base for us, it is both. It is truly and honestly from day one, both. You cannot be designing outside in or just designing inside out. Now, when you look at developers there, coming in from my initial reaction, which I mentioned at the beginning of this discussion, which is that this whole the glass or the system of or the envelope that we are talking of instantly gives you a far better finished look to a building, making it smarter, more marketable. You cannot deny that, and it's also faster. So being coming to site, getting installed there is an instant transformation of what might not be looking for. But now where the trend is getting a little, what is bucking the trend here is precast has come in a big way, and some of the panels that are reaching the site, you look at it and you might have designed for the exterior facade to get some other element onto it, and you do a rethink there and stand at site and say, we really need to do that. And ditto on the inside, we really need to go and plaster stuff. There is greater acceptance, Ravi, as you know, and we have done many projects or some projects which are of that kind, of the industrial look, the industrial aesthetic, where the unfinished look is gaining better acceptance. So it's a trend that you see over, if you were to look at the last 24, 25 years, glass appeared, glass got a huge market, then there was a reaction against it, and then the builders and everybody says, okay, let's keep persisting with it because we can get a finished look to the building. And now you have this whole aesthetic, the sensibility is that if I get something that is finished well, no doubt, but it is industrial looking, it is very, very acceptable. And we are doing a few projects right now as I speak, which explore that to the T on the inside for a corporate office. So it's the it's changing all the time, Ravi, and that's great it is changing, because otherwise you and I and others will be a very bored set of people. So it's everything. It's everything. You keep reacting it, and when portfolios are large, you react to a client, and the client is a very, very important part of any project. The finances coming from there, it's their building, and you react to what they want, and you try to do the best that you can within those parameters to create a successful project.
I must share my experience when I was doing this building in Shanghai for Sabik, it was fascinating that, every panel of the wall elevation was analyzed for its reason, because it was a laboratory inside. It was also an exterior of the wall, and it was very interesting that the client was equipped to understand this implication as we did the design. And to me, to be part of that forum was fantastic, to build something like that in Shanghai. So I think it's very relevant that we all must introspect and ask this question much larger. I think let me summarize this panel discussion with my last round of question or a statement, and I would want everyone to take turns and react, and we'll wind up the discussion. There's a montage, because we have an architect who comes as the lead to create the possibilities of what the client aspires. The client is super most important to invest and build and vision. And of course, there is the glazing consultant who will programmatically, format what has to be drawn up, and also guide and create the document that a contractor will take the liability and build eventually. And of course, suppliers as Gala, will do the best of the materials for us to sort of incorporate and build in the way we can build. But given a choice, who must be the super priority? It's easy to say all of us have to work together. That's being very fair. But if one has to take that strike, Arun, what do you think?
So I think it's a dance, it's an orchestra, and the architect has to be holding the baton, standing center and conducting it. So the architect's role as a conductor of the piece is where my mind is, but the client is the producer, as the financier, and you can take that simile forward. To me, it's the architect as the conductor.
Tilak?
Yeah, very similar point of view, in the sense that I always, tell my architects in-house that we as architects have that lead role, which then oversees everyone's role. So when you're designing, you take into cognizance the client's economic issues, the contracting abilities, the the material availability in that location, in that particular location that you're working in. You are the one who has to really tie that whole thing in. You can't just think solely design and then leave everything to chance. So I think the architect plays a massive role in making sure that naturally, if you give anyone, if you give everyone equal status, it's not going to happen. The architect does have to play that role. Client has to recognize that. Let us play our role. Not interfere too much in that role. We done our job well. Dreaming, that's the wish, the one. That's the one that
I think for me, the lead has to be the budget. And what I observed in our country is that most of the developers are shopping all the time. They don't know what they want, and it ultimately boils down to a number. If they have a number up front in their head, what they want to spend, it might give flexibility for others, to achieve something to that number. That's very important. Nobody gives much thought about it, that, actually we don't have a definite budget for the facades or the envelopes. That has to change.
Sir, like everyone mentioned, I personally believe that, architects and consultants play a leading role in taking everyone together, including the client and the manufacturers. Also, being a manufacturer, I personally feel that we play a supporting role into turning design into reality. So being able to produce good products helps the design turn into a great building practically. So again, it's a team effort. It will always be a team effort, and there should also be a healthy knowledge session between the architects and the vendors sometimes, so that we understand the upcoming design trends and everything, and where we should take our product to, and in which way or what direction we should take our designs and everything ahead. So we are not complacent, and we want to develop more designs. So to make sure that we are with the designs and the vision of you all.
I'll have the lady have the last word. Gayatri, she's working with me for the Boeing campus, and what is fantastic is she is a super knowledge capital. She is gorgeously arrogant. She knows how to tame the client and get what we have to do. She does more talking than I do, which is so beautiful. So Gayatri, what would be your response to the point of?
So I would say that yes, the architect definitely has the lead role in terms of driving the entire project, because you are responding to what the client's requirement is. Facade consultants do play a major supporting arm role to the architect, like we've done with all of y'all on various projects. And slowly, I would say the recognition is coming that engineering is a skill which has to also be considered. It's no longer a direct a limitation of what a particular set of manufacturers or a particular set of contractors may have been exposed to. So I would say that architects definitely are the main role. Facade consultants are in certain places playing great supporting roles. And budgeting, of course, like Anwar says, it's important. But in the projects that we work on, we make sure that the clients have realistic budgets with them. And we don't sign off on tenders or start issuing tenders till we have a sign off on that budget amount. So we do all the iterations, it goes back and forth with architects. But once the client signs on, they know exactly what they're going to spend on that facade.
Super. Each open window is a God's way to make you admire nature and his creation. So for us, I think as long as we hold that consciousness, I think it's fantastic.
I'm going to leave, guys. Thank you so much.
Thank you.
Thank you, Ravi, for moderating this so wonderfully, and my co-panelists so much. It was a really wonderful discussion, and iDAC, thank you for inviting me over as well. Sorry, guys, I got to leave. Thanks.
Okay, thank you.
Thanks, bye.
Thanks, everyone.
All right. Thanks, everybody.
Thank you.
Thanks, Ravi, for inviting me. Thanks, iDAC.